video, we will learn about the different parts of a circle, including how to identify the key parts of a circle from the diagrams given here. So we will know how to identify the key parts of a circle from the definition of each one. So what are the parts of a circle? So the parts of a circle are the radius, diameter, circumference, arc, chord, secant, tangent, sector, and segment. So let's define what a circle is. So a circle is a round plane figure whose boundary consists of points equidistant from a fixed point. Let's say the point is this one, and we call this point as the center of the circle. So the center of the circle is the fixed point from which all points on the boundary of the circle are equidistant. So from this point to any point on the circle, the boundary of the circle, are equal. And then we have the radius. So the radius of the circle is from the center to any point on the circle, and the radius is half the diameter. So this is the diameter here. It's indicated here, and also this one here, and this one here, the red line or segment. And diameter is the distance across the circle passing the center. So from this point to this point here, and it has to pass the center of the circle, then that is the diameter. And then the circumference. The circumference is the distance around the circle. So the whole thing here, that is the circumference. And then we have the arc. So the arc is just a part of the circumference, this one here, or let's say this one here. So we have the minor arc and the major arc. So the major arc is greater than half the circumference, while the minor arc is less than half the circumference. So half the circumference is just 180 degrees. And then we have the chord, this one here, or this one here. So the chord of a circle is a line segment going from one point of the circumference to another, but does not go through the center, because that one that passes the center is the diameter. So any line or segment that goes from one point of the circumference to another, but that does not go through the center, is called the chord. I meant the chord is a segment, not a line. Okay, and then we have the secant. Secant here is a line that goes through the circle at 2 points. So this is our secant here. Then we have tangent, okay, this line here. So the tangent of a circle is a straight line that touches the circle at a single point only. So this is the point of contact, or we call it as the point of tangency. And then we have the sector. So the sector of the circle is a section of the circle created by two radii. So your radius here, one radius and another radius, they form this section here, and we call it as the sector of a circle. And then we have the semicircle. So the semicircle is just half the circle, or half of a circle, and could also be considered a sector, where the circle has to be splitted by the diameter. And then we have the segment. So the segment of a circle is a section of the circle created by a chord. So this is our chord here. So this section here of the circle created by this chord here is called a segment. And let's take note that the measure of the angles around a circle or around a point are equal to 360 degrees. And now let's identify some central angles, inscribed interior and exterior angles of a circle. So the central angle. So the central angle is the angle formed by two radii. This one radius in and one radius here, from the center of the circle. So this is our central angle, and this one is just equal to the intercepted arc. Okay, and then the inscribed angle and the inscribed angle of a circle. Okay, this is the inscribed angle of a circle, which is just one half of the central angle, or the intercepted arc. Okay, now let's identify these angles, these types of angles here. Okay, we're given here the first figure. So what type of angle is this? This one here. So that one is an inscribed angle. And CB, this one here, CB is a chord. And the measure of angle B, this angle here, is just one half of the measure of this one, the intercepted arc, which is 120. So that is one half of 120. So that is just equal to 60 degrees. And then the next figure is still an inscribed angle. This angle here, angle ABC, that one is an inscribed angle. And then CB is a chord. Oh, I think it's the same problem, so let's just skip that one. Okay, so the next figure, we're given here this angle 116 angle DEF, which is equal to 116 degrees. So what type of angle is this? So this one is the central angle, and DE here, okay, from the center of the circle to any point, to point D on the circle, is just the radius. And then arc, the measure of arc DF here is just equal to the central angle, which is equal to 116 degrees. We have examples here of exterior angles and interior angles. So this one is an interior angle, as well as this one. This one is an example of an exterior angle. So the type of angle is interior angle. And then GH here, okay, this line segment here is a chord. And then the measure of angle K, so the measure of angle K here is just the sum of the major arc and the minor arc divided by 2. So that is 210 degrees plus 54 degrees over 2. So that is just equal to 132 degrees. So that is how to solve for the interior angle of a circle. You add the major arc and the minor arc divided by 2, and half of it, half of the sum of the arcs. Okay, let's go to the next problem. So in the figure here, the type of angle that we're going to identify is this one. So that one is an exterior angle. And then LN here, LN, line segment LN, is a secant. And then arc TP here, the measure of arc TP here. Okay, to solve for the exterior angle, you just have to subtract the major arc and the minor arc. So that is divided by 2. So that is the measure of the exterior angle. So that would be arc TP, or the measure of TP, arc TP. So that would be arc TP minus this arc here, which is 50 degrees, divided by 2 equals the exterior angle, okay, this one here, which is equal to 34 degrees. So it will be TP minus 50 equals 34 times 2. So that would be arc TP minus 50 equals 68. Okay, solving for TP. TP is just 68 plus 50. Therefore, the measure of arc TP is just equal to 118 degrees. Okay, let's solve some more problems here. So in the first figure, we're given here this arc, which is equal to arc AC is equal to 68 degrees, and we need to find this angle here, angle X. So from this figure, angle X here is an inscribed angle. Therefore, angle X is just equal to this arc divided by 2, a half of that one. So this is just equal to 34 degrees. Then for the second figure, we're given the value of the inscribed angle, which is 26 degrees, and we solve for the arc, which is W. So W is just twice the inscribed angle. A W here is just equal to 52 degrees. And then the next figure, we're given the major arc, which is equal to 142 degrees, and then the minor arc, which is 36 degrees. We solve for the exterior angle. So to solve for the exterior angle, that is the major arc minus the minor arc divided by 2. So that would be equal to 53 degrees. So that means the exterior angle P is just 53 degrees. Okay, let's solve some more here. Okay, we're given here the major arc and the exterior angle. We need to solve for the minor arc. So exterior angle is 18 degrees. So that is 18 degrees equals the major arc, which is 138 minus K over 2. So this is just, okay, we multiply both sides by 2, so that this is 18 times 2 equals 138 minus K. So this is 36 equals 138 minus K. We subtract 138 from both sides. So we have negative 102 equals negative k, and we divide both sides by negative 1. So the minor arc is just equal to 102 degrees. This one, 102 degrees. Okay, and for the next figure, we're given here the intercepted arc DB or BD equals 90 degrees. We need to find the central angle X. So since the central angle is just equal to its intercepted arc, so the central angle is just equal to 90 degrees. Then the next figure here, we're given the major arc, which is equal to 212 degrees, and the minor arc, which is 110 degrees, and we need to solve for the interior angle. So the interior angle Z is just equal to its major arc plus the minor arc divided by 2. So that would be 322 divided by 2 equals 161 degrees. Therefore, the interior angle here is just equal to 161 degrees.